I know proto and prototype are confused often, so that's why I wanted to dedicate another example just to help solidify your understanding of these two concepts. Let's have a look. The first thing I want to show is proto, __, proto, __. Let's see how that works. Let's define a user of our website. Let's just say it's got one property which is false, and that is this person a member or not? And now let's create a guest user. And say the guest user has a name of Wally. Now, what are prototypes? We've kind of seen that prototypes are just referencing another object, and it allows one object to use properties and methods defined on another object. That's all it is. It's almost like delegation. So let's now take our guest user and set its prototype to the user object. Well, one way to do that is we can access the global object. We can use an inbuilt method called setPrototypeOf, and we're wanting to set the prototype of guest user to user. Now this means our guest user automatically has access to the member property. And if we console that log out, we get false, which is what we set on the main user object. So this is fine, this is intuitive, and this is what prototypes are all about. If we console log guest user out to the screen and we open up its object, we get this proto here, which is an object. And we open that up, and that object, you can see now, has a property of member false. So this proto is actually referencing the exact same object of user. And in fact, it's not creating a replica of it. It is literally the same object. So that just means if I go now and I change user, if I change the user and I add a property called age, that's actually now going to have updated the proto of guest user. And to prove it, all we have to do is go guest user, and let's just console log this proto property out to the screen directly. There you go. It's updated its proto, which is now an object consisting of both member and age. Okay, so that's proto. Kind of intuitive, right? What about prototype? What is that about? Okay, well, let's start having a look. Let me just clear the console. Let's create an empty function. This will help illustrate prototypes. Let's call our function car, and let's just say it's empty. Then on this car function, let's set a prototype. And let's set the prototype, let's just call a property of sound. We can make it whatever we want. And let's say that sound has a value of vroom. Okay, this is the first step. We've defined our object. The second step to constructor functions is that we have to call it by using the new keyword. So let's just define my car equals new car. And then we know that my car has access to the sound property. And remember what the new keyword does here. This is why I just want to emphasize it once again. The new keyword creates an empty object, just a simple object. It will then encounter that car function, and it will look at that car function's prototype, and it will set the proto of the newly created object to be that prototype. Then what it'll do is it'll pass in the newly created object into the car function, and then this keyword will point to itself, the my car object. It's kind of what happens in the background. And this is the only reason why this prototype property exists. It exists so when we use the new keyword, it's able to set the proto of the newly created object. You kind of get it? Let me prove it to you. Let's take our my car and let's console log out proto. What would you expect to see? What is its proto? Remember what we said, its proto will be the prototype we set on the function car. And it is. It's sound. Vroom. But do you think our car is going to have its own prototype? Let's have a look. Prototype. It's undefined. It doesn't have a prototype. And this is the point I'm trying to make. Only functions have prototypes. And it's only there so when we use the new keyword, it can set the proto of that to the prototype of the function. And functions automatically get prototypes. Let me show you another example. Let's create a function called bike. And let's go bike.prototype. And there you go. Its prototype is an object. It does have a prototype. This is the point I'm trying to make. But what about objects? Objects don't have prototype. It's only these functions for these scenarios. Let me give you another example. Let jet, I'm trying to think of another. We've used car, we've used bike. Let's use jet. And let's just say that is an empty object. Does jet have a prototype? No, it doesn't have a prototype because it's not a function. But jet does have a proto. But where is that proto from? First let me show you that it has a proto. Proto. There's its proto. But what proto is that? And where has it come from? Well, defining an object like this is the same as us going let jet equals new object. So what it's doing, and we've used the new keyword here, this is a function. And remember, the proto of jet is going to be set to the prototype of this global object. So it's no surprise that jet does have a proto. And I can prove that it's a global object. Because what we can do is we can go console log jet proto. Does that equal the object prototype? And it's true, it does equal. They are exactly the same thing. It's referencing the prototype of the global object. And this means, and I know it's going to sound very strange, but this means the actual global object is a function. I can prove it's a function by executing it. There you go. It's a function. How amazing is that? So, to recap, underscore underscore proto underscore underscore is available on objects, and all that's doing is it's referencing the prototype of another object. That's all underscore underscore proto underscore underscore is. And prototype, which we've just seen, well, that is only available on functions, and it only exists because we like using the new keyword. Whew, I hope this is starting to make sense. But don't worry if it is confusing. I mean, a lot of people struggle with these concepts in JavaScript. Let's continue.